In this particular question, we have to find out the term that is independent of x for the given binomial expression. So we begin by assuming that our r plus 1th term doesn't contain x, or we can say it's independent of x. Then we begin by finding out the r plus 1th term, which will be simply equals to 8cr times the first term, which is half x raised to the power of 1/3 raised to the power of 8 minus of r, times the second term, which is x raised to the power of negative 1/5 raised to the power of r. That will be equals to 8cr times 1 raised to the power of 8 minus r, which is going to be 1, times x 8 minus r divided by 3, all divided by 2 raised to the power 8 minus r, times x raised to the power of negative r over 5, which is equals to 8cr times 1 over 2 raised to the power of 8 minus r times x raised to the power of 8 minus r over 3 minus r over 5. We combine the value of the exponent of x, and that gives us 8cr times 1 over 2 8 minus of r times x raised to the power of, so we find out the value 8 minus r over 3 minus r over 5, which will be equals to 15. 3 times 8 times 5 is 40. 40 minus 5 of r minus thrice of r, which gives us 40 minus 8r divided by 15. So this is the exponent of x. So we have 40 minus 8r divided by 15. So this is our r plus 1th term. Now, in order to find out the term independent, now this is the term that is independent of x. So we let 40 minus 8r, the exponent of x, equals to 0, which will give us 40 minus 8r equals to 0 times 15, which is simply 0, implies 8 of r is equals to 40, which is equals to r given by 40 over 8, which is 5. So this is the value of r. Now let's plug this value of r into tr plus 1, and that should give us t 5 plus 1 equals to 8c5 times 1 over 2 raised to the power 8 minus 5, and that is cubed, times x raised to the power, so when we substitute the value of 5 into the exponent of x, that gives us a 0, which is equals to 8c5 times 1 over 8. So this is the term which is independent of x, and that is our 6th term. Let's go to the next question. So here we are to find out the term which is independent of x in the given binomial expression. So we start by assuming that our r plus 1th term. So in this particular question, we have to find out the term which is independent of x in the given binomial expression. So we begin by assuming that our r plus 1th term is the same as the previous one. So we'll assume that the r plus 1th term is independent of x. Then we try to find out the r plus 1th term, which will be equals to 9cr times the first term, which is x squared raised to the power of 9 minus r, times negative 2 over x raised to the power r, which will be equals to 9cr times x raised to the power of 2 times 9 minus r will give us 18 minus twice of r, times negative 1 raised to the power of r times 2 raised to the power of r divided by x raised to the power of r, which is equals to 9cr times negative 1 raised to the power of r times 2 raised to the power of r times x raised to the power of 18 minus the thrice of r. So this is our t r plus 1th value. Now, in order to find the term independent of x, so we allow 18 minus thrice of r equals to 0. Such that we have a thrice of r is equals to 18 and r is equals to 6. So we have the r value. Now let's substitute the value of r into this particular equation. So we have t 6 plus 1, which gives us 7, equals to 9c6 negative 1 raised to the power 6 times 2 raised to the power r, which is 6, times x raised to the power of 0, which is equals to 9c6 negative 1 raised to the power of 6 is positive 1, 2 raised to the power of 6, and x raised to the power of 0 is going to be 1. So this is the term, the seventh term is the one which is independent of x. We can go ahead and calculate the value of 9c6 times 2 raised to the power of 6, and that will give you the answer. Let's go to the next one. So we have to find out the term which is independent of x in the given binomial expression. Going in a similar fashion, we assume that the r plus 1th term is independent of x. This is the independent term. And then we find out the value of t r plus 1, which will be simply equals to 10cr times x squared over 3 raised to the power of 10 minus r times negative 3 over x squared raised to the power r, which will be equals to 10cr times x raised to the power 20 minus twice of r divided by 3 raised to the power of 10 minus r times negative 1 raised to the power of r times 3 raised to the power of r divided by x raised to the power of twice of r, which is equals to 10cr times negative 1 raised to the power of r times 3 raised to the power of r minus 10 minus r. So what we have done, we have taken the exponent of 3 in the denominator and subtracted it from the exponent of 3 in the numerator, which leaves us with x. So we have x raised to the power of 20 minus 2r minus of twice of r, which is equals to 10cr times negative 1 raised to the power of r times 3 raised to the power of twice of r minus 10 times x raised to the power of 20 minus 4 times of r. So this is our r plus 1th term. Now what we do, we try to find out the value of r by letting the exponent of x, which is 20 minus 4r, equals to 0. So we do this, and this should give us 4r is equals to 20, which implies that r value is equals to 5. Now we replace r by 5 into our tr plus 1. So that would give us t5 plus 1 equals to 10c5 times negative 1 raised to the power 5 times 3 raised to the power, so 2 times 5 is 10, 10 minus 10 gives us 0, times x raised to the power 0. So the final answer would be negative 10c5. So we can find out the value of 10c5 using a calculator, and the value is 252. So we have the sixth term, and the value of the sixth term is negative 252, and it is independent of x. So that's the answer. Let's go to the next question. So we have to find out the independent term. So let's go the usual route. So we have r plus 1th term, and that is going to be independent. And then we find out tr plus 1. So tr plus 1 is equals to 12cr times the first term, which is twice x squared raised to the power 12 minus r, times negative 1 over x raised to the power of r, which is equals to 12cr, times 2 raised to the power of 12 minus r, times x squared raised to the power of 12 minus r, so that would give us 24 minus twice of r, times negative 1 raised to the power of r divided by x raised to the power of r. So this is equals to 12cr times negative 1 raised to the power of r times 2 raised to the power 12 minus r. This is 12 minus r. Let me rewrite it. 12 minus r times x raised to the power 24 minus thrice of r. So this is our t, r plus 1 value. Then we let the exponent of x, which is 24 minus 3r, and equate it to 0. That would give us thrice of r is equals to 24, which implies the value of r is 8. Now we substitute the value into tr plus 1, so that should give us t, 8 plus 1 is equals to 12c8 times negative 1 raised to the power 8 times 2 raised to the power 12 minus 8 is 4 times x raised to the power of 0. So which is equals to 12c8, negative 1 raised to the power of 8 is positive 1, and 2 raised to the power of 4. So this is the term which is independent of x. You can go ahead and find out the value of 12c8 and then multiply it to 2 raised to the power of 4. I'm leaving it here, so both the answers will suffice. Let's move on to the next. So here we have to find out the term which is independent of x in the given binomial expression. Same way as before, so our r plus 1th term is going to be independent term. Then we find out the t, r plus 1th value, which is equals to twice n c r times x raised to the power of 2n minus r times 1 over x whole raised to the power r. So this is equals to 2ncr times x raised to the power of 2n minus r divided by x raised to the power of r. Then we combine the exponents of x, so that should give us x raised to the power 2n minus twice of r. So we equate 2n minus 2 of r equals to 0, and that gives us r is equals to n. So this is the value, and then we substitute here into t, r plus 1 into this particular equation. That should give us t, n plus 1 is equals to 2n cn x raised to the power of 0. So we see that the n plus 1th term is the one which is independent of x, and its value is simply 2ncn. That is the answer. Let's go to the next one. So here we have to find out the term which is independent of x in the given binomial expression. Now this is not exactly a binomial expression, so what we have to do first is a trinomial expression which is multiplied to a binomial expression, and when we expand it, so we will get a term and that will be independent of x. In order to do this particular type of question, what we have to do, we have to find out the term, the general r plus 1 term of the second expression. So let's do that. So we'll do step by step. First we try to find out, let us first find out the r plus 1th term for the second expression, which is 3 over 2 x squared minus 1 over 3x raised to the power of 9. So we'll get t, r plus 1 equals to 9cr times 3 over 2 x squared raised to the power of 9 minus r times negative 1 over thrice of x. This 3 looks very odd. Let me fix it. So this is 3. Negative 1 over 3x raised to the power of r, which is equals to 9cr times 3 raised to the power 9 minus r times x raised to the power 18 minus twice of r divided by 2 raised to the power of 9 minus r times negative 1 raised to the power of r times 1 divided by 3 raised to the power of r times x raised to the power of r, which is equals to 9cr times 3 raised to the power of 9 minus r minus of r times negative 1 raised to the power of r times x raised to the power of 18 minus 2r minus r whole divided by 2 raised to the power of 9 minus r. Now we further simplify it, and that should give us 9cr times 3 raised to the power of 9 minus twice of r divided by 2 raised to the power 9 minus r times negative 1 raised to the power of r times x raised to the power of 18 minus thrice of r. So this is our t, r plus 1 at value for the second part. Now what we do, we take it and multiply it to the first part, which is 1 plus x plus 2. So let's take this. So we have 1 plus x plus 2x cubed. Let me recheck. Yep, it's 2x cubed times 3 over 2 x squared minus 1 over 3x minus 1 over 3x. So this was our original expression. What we have done is like we have found out the r plus 1 term for the second part. So what we're going to do, we'll keep the first expression the way it is. So it will be 1 plus x plus 2x cubed, and then we replace it by tr plus 1 by the general term, we can say. So we have 9cr times negative 1 raised to the power r times 3 raised to the power of 9 minus 2r divided by 2 raised to the power of 9 minus r times x raised to the power of 18 minus thrice of r, and put the entire thing inside the parentheses. Now what we're going to do, we're going to distribute each of the term for the first expression with the general term of the second expression. So 1 times the entire thing gives us 9cr negative 1 raised to the power of r times 3 raised to the power of 9 minus 2r divided by 2 raised to the power of 9 minus r times x raised to the power of 18 minus thrice of r. So let me copy this part, plus x times this term. So we have 9c. So what we do, we rewrite it, and this whole entire term is multiplied by x. Similarly, the third term will be, I don't have enough space, so I'll write it downstairs, plus 2x cubed, which is our third term, and we're going to multiply it to the general term. Now that should give us the first term plus the second term. The second term, we have the x which was distributed with it. So we have x, the exponent of x as 1, so that will get added to the exponent of x of the general term. So that should give us this will be plus 1. And then we have the third term, so we have x cubed here, so we'll have plus 2 times the general term, and we have an x cube here, so we will add the coefficient, the index of x to the index of the general term of x. So there we go. So we have this final value, so let's rewrite it, and that should give us plus this will be now 19 minus thrice of r. So this will be 19 minus thrice of r, and the final term will be 2 times so it will be 2 times oops, let me fix this too. So we have 18 plus 3, that will be 21 minus 2r. So this is what we have got. Now this is our first term, this is our second term, and then we have the third term here. Now we're going to do it step by step. So in the first equation and the first term, so let us suppose that 18 minus thrice of r is equals to 0. That would make the term independent of x, and from here we try to find out the value of r, which will give us thrice of r is equals to 18. So r is equals to 18 over 3, so it's 6. So that's the value of r here for the first term. Now this is primarily for the first term. So we have the first term, so we replace the r by 6 here. So let us do that. So that would give us 9c6 times negative 1 raised to the power of 6 times 3 raised to the power of 6. 9 minus 2 times 6 is 12, so that will give us a negative 3 here, over 2 raised to the power 3 times x raised to the power 0. So that will be equals to 9c6. Negative 1 raised to the power of 6 is positive 1. Then we have 1 over 2 cubed times 3 cubed, so which is 6 cubed, and the value of 6 cubed is 216. And we multiply 1 over 216 to 9c6, and that should give us 7 over 18. So this is the first one that gives us, the first term is giving us 7 over 18. Now we move on to the second term. So in the second term, we'll try to make it independent of x, and similarly for that we have to make 19 minus 3r, which is the index of x, equals to 0. But here we see that this gives us thrice of r is equals to 19, which implies r is equals to 19 over 3. So that 19 over 3 is not a natural number, so this term is not independent of x. So we cannot assume any value of r that's going to make this particular term independent of x, so we skip it. Now we move on to the third term. So we have the third term. So here we allow the index of x, which is 21 minus thrice of r, equals to 0, and try to solve for the value of r. So we have thrice r is equals to 21, which gives us r is equals to 7. Now this being a natural number, so that means this definitely is independent of x. And what we're going to do, we're going to replace the r value by r. R is 7, and let's try to find out what's the value going to be. So it's 2 times 9c7 times negative 1 raised to the power 7 times 3 raised to the power 9 minus 2 times 7, which is 14. So 9 minus 14 gives us negative 5, divided by 2 raised to the power 9 minus 7, which is squared, times x raised to the power of 0. So this is finally 2 times 9c7. So 9c7 gives us 36. Negative 1 gives us negative 1 raised to the power 7 gives us a negative number, divided by 2 squared is 4 times 3 raised to the power of 5. And when we do the computation, and that gives us negative 2 over 27. So this is also independent of x. Now what we have to do, finally, we have to add the first term and the second term, because both of them are independent of x. So we add 7 over 18 to negative 2 over 27, and that gives us 17 over 54. So the term which is independent of x has the value 17 over 54. So that is the answer, and that's the first term and the third term.